So now that we've had a chance to use some of the built-in functions in Python, use some of the built-in methods, let's go ahead and learn how to write our own. So what's a function? So a function is simply a specification where you give it some arguments, it performs some calculation, and it returns a value. Pretty much just like in math. So far we've covered the mechanisms. It is entirely possible to write an entire program without functions. In fact, that's usually if you've ever heard of Fortran, that's usually the Fortran way of writing 100,000 lines all without functions. But no, I mean, functions, it allow you to write clean, modular, and reusable code. Okay. Okay. So let's go over this. So let me give you an example of a function, and then I'll talk a little bit more about it. So like I said, we've used functions. We've used the len. Len is a function where you give it a sequence, and it gives you back its length. We've used methods methods is nothing more than a function that's attached to an object that acts on that thing. We've used those, so now we can write our own. So we write a function using this syntax. We use the def. Def is the first word we write. So we can do def. Okay. The name of the function is even. Parentheses. Now we give the arguments to the function. And then this one will be a single argument, I. Semicolon. Now if you want to have a string in here, that is entirely optional. It's recommended, but it's entirely optional. But this is what's called your documentation string. And then you do this with the triple quotes. And then you can do, this is the function that no. Okay. And entirely optional, recommended. It's just a way to document what that function does so other people can more easily use it. Okay. And then you write the body of the function. So you notice that it's indented one block. Percent. So great. So now I've defined a function. A function, that too is an object. So let's see what it looks like. Is even. It shows that it's a function. Okay. Doc. Oops. Okay. Every object in Python will have this funny little thing called an underscore doc underscore. That's what's called its documentation string. So if we do A, okay, so A is a list, you can do A dot underscore doc. And that is, it's a list. Okay. Stir string. Okay. The string, it's creates a string. Okay. So everything has that little funny little underscore underscore dot, and if you run across some object, you can just type that and type that property and then access its documentation string. So now if we want to call it, we simply just do false. Okay, great. That's pretty simple of making functions. So it's just def, name, arguments, and then a body of things to do. Okay, so in the body, like I said, we have the documentation string, optional, run some commands, and then you have, then it's keyword return. So when I define this guy, return, okay, yeah. The return statement, that's the value that actually gets returned from the function. So in this one, I'm returning the result of that expression there. And then you can return an object, you can return a number. It's up to you, the designer of the function, to return what is appropriate. Okay. When I call a function with an argument, what happens is it makes a copy. If what I'm calling it with is a scalar type like a number, Python makes a copy of that. Okay, so if I do this, I will do def f by parameter. Print x. So I can do F4. Okay, so should be fairly straightforward. But what if I do this? X equals 0. Then I can do F1. Ah, look, X is still 0. Okay, because it made a copy of it. I can define variables inside of my function. And then those variables that exist inside of my function definition, those only live inside of that function. When that function goes away, everything you declared inside of it also goes away. So printf, okay, yeah. So we have, and this is what we call scoping, okay? So when I made the symbol X, I've defined that in what's called global scope. And a scope, you can think about it as like a rifle scope of what's actually in your field of view, what you can actually see. So if it's global, that means it exists outside of any function definition. But if I define a function here, that's a new local, that's what's called a local variable, okay, local. That exists outside of global space. So as this function is valued, okay, so in this call here, I called f with x. I passed it 0, okay. I made a copy of that, it evaluated some code, it did some assignments, and it returned the value. Okay. If you want to return something from a function, you always need to use the return keyword. So if I don't add a return, it's not going to return. I mean, it'll perform calculations, but it won't actually return anything. It won't return any values unless I use that return keyword. So a little difference here is return versus print. So return, that actually returns the value that it calculated. Print simply prints it to either the Jupyter Notebook console or whatever console you're on. If you return a value, that value can be used by whatever other code called your function. If, however, you print it, that's only visible to you, the user of it. No other calling code can access what it actually printed. So that's why it's important to actually return stuff. Okay. Modules. So Python organizes code into what's called a module. Basically, every file, xyz.py, that's what's called a module. And then you access modules by using the import keyword. Okay. So by default, there's only a few built-in global scope function definitions. If we want to access more stuff outside of there, we have to use the import keyword. So we can do import sys. Okay, sys, that's a system module where you can access functionality. You can do sys dot add version. Okay. So it's using the Python version 3.6.5. Sys dot version info. Lots of fun stuff. We can do import math. Sign. Okay. We do math.sign. All of the fancy math functions, sign, log, all those things, those are available in the math module. They're not available default when you first run Python. So, and if you don't like typing math.this, math.that, if you use them all the time, you can do this from math import star. That imports everything. Now we can do sign. Okay. So I'm going to skip over composing functions because you're not really going to be doing that a whole lot in this, in either Torium or CompuCell. Okay. Yes. By definition, when we create a myfile.py, by definition, that is a module. So if you write that and you have some really useful stuff in there, you can simply do import myfile.py, and actually just import myfile. That's literally all you have to do is just type stuff into a file, and it's automatically a module.